Dear students, today we are going to discuss about introduction about trees and types of trees. So these are the topic we will cover in the fourth unit. Before starting the presentation, we will discuss about the course learning outcome. After completion of the fourth unit, student will be able to organize the data using non-linear data structure with trees and graphs. So already we have discussed about the linear data structure. We know that stack, queue, linked list, like that. Already we have discussed array, like that. So now we are going to discuss about nonlinear data structure like trees and graphs. So this presentation mainly concentrate on trees and its types. So I written the CO like after completion of this presentation, students will be able to understand the trees and its types. So initially, what is tree? A tree is a recursively defined as a set of one or more nodes. So here nodes are there, one or more nodes are recursively defined here with the set of nodes. One node is designated as the root of the tree and all other remaining nodes can be partitioned into non-empty sets, each of which is a subtree of the root. This is a diagrammatic representation of the tree. So this is tree. So here A is the root node because topmost element of the tree is called like root node. So here three branches are there. So this is one of the branches and this is one of the branches and this is one of the branches. So it is a separate subtree. This is the separate subtree. So this is the subtree. So now you know this is the tree. So this is the root node. So these are the subtrees. Subtrees called like T1, T2, T3 here. T1, T2, T3. So here some basic terminologies, like basic terms we will discuss now. So first node. What is node? A node is a structure which may contain a value or condition or represent a separate data structure. Okay. So here the circle will be represent node of the particular tree. And root node that we are discussed now. The top node of a tree is the root node. If root equal to null, then it means that tree is empty. The circle will be mentioned as node and then links will be mentioned like edges. Okay. So next one, leaf node. What is leaf node? I already told. Leaf node means there is no children of the nodes. Here G, F, H, D. These are the terminal nodes or leaf nodes. Okay. Then siblings. What is siblings? Siblings means all the nodes that are at the same level and share the same parent are called siblings or brothers. So here B and C have the same parent A. So B and C are siblings. Same like that D, E, F. So these three have the same parent. So these three are siblings. Clear? Subtree already we have discussed. Now we are going to discuss about path. What is path? Path means it is identifying the root to root node to leaf node. So here in case I will consider 10. So how to find the root? So 10 have the parent 9, 9 have the parent 7, 7 have the child of root node. So 11, 7, 9, 10 is the root. Clear? Same like that I given the example here. So 11 to 6. So 6. So how 6 will be joined with the root node? That is the path. Okay. Leaf node to root node, we are finding the path. So path is 6, 5, 7, 11 or 11, 7, 5, 6. Okay. Next one, level number. What is level number? Every node in the tree is assigned a level number in such a way that the root node is at level 0, children of the root nodes are level 1. Like that, every node is at one level higher than its parent. Okay. So example, the root node have the level 0. Okay. So this is level 0 of root. Then it's how the child node, it will be higher than this level, that is 1. So for this level, level 2, this level, level 3. So in this tree, maximum level is 3 because 0, 1 level, 2 level and 3 levels. And then degree. What is degree? Degree of a node is equal to the number of children that a node has. The degree of a leaf node is 0, we know that, but some of the nodes have the children. So that is degree of the particular node. How many children are there? That is degree of the particular node. And what is in degree? What is out degree? In degree of a node is the number of edges arriving at the node. Because if the root node is there, root may be partitioned into left and right. So left and right means the root node don't have in degree, but root node have out degree. 2 out degree is there. In case left child and right child is there, that is out degree. So out degree means the number of edges leaving that node, that is out degree. From here, in case 11 have no in degree, but it's have 2 out degree. In case we will consider 5. So 5 also have 1 in degree and 3 and 6 are out degree. Okay. So now we will discuss about the types of trees. So we have 6 types: general trees, forest, binary tree, binary search tree, expression trees, and tournament trees. So this is a general tree. We know that in a real tree we know that the real tree have root and then many branches are there. The branches have again branches are there. So finally it is reached the leaf nodes. Okay, so the same method we are implemented here. This is root, and this is subtrees. Branches are called like subtrees, and end of the trees is nodes are called like leaves. So leaves have no children. That means no further divisions. Leaf is the final one in the real tree. The same structure we are used in the general tree. Okay. So normally it is the data structure. It stores the elements hierarchically from top to bottom. Okay. So top node is the root node, and then last node is the leaf node. Intermediate nodes are called like parent nodes of leaf nodes. And then forest. The next type is forest. What is forest? A forest is a disjoint union of trees. A set of disjoint trees is obtained by deleting the root and the edges connecting the root node to the node at level 1. So in this diagram, this is the level 1. B, C, E are in level 1. Just we are removing the root node and removing the edges from the level 1. So that trees are called like forest. Clear? So from this node, I am removing root node and removing these 3 link. Okay. So that is called like forest. Next one, binary tree. What is binary tree? So we know that binary means zeros and ones. Okay. So zeros and ones means 2, the maximum 2. So that is called like binary tree. So in the binary tree, the node have maximum at most 2 nodes. That is called like binary trees. Okay. The node have no children or 1 children or 2 children. At most 2 children only. Not more than that. So in case there is no children, that node may be the leaf node of the tree or terminal of the tree. Okay. In tree data structure, every node contains data element, left pointer and right pointer. So previous linked list, we know that we are creating structure for node and next pointer. Here we are creating one more pointer, that two pointer we are creating for the tree structure, and then in that the left side one is the left pointer, right side is the right pointer is there. So we can create two pointer, one data element. The data element represent the data values, and then left pointer is pointing to the left child, right pointer is pointing to the right child. In case root equal to null, that means the tree is empty. Okay. So now we will discuss about depth and height of the tree. Depth of the tree. What is depth of the tree? The depth of a node n is given as the length of the path from root to the node n. Okay. The depth of the root node is 0. Root node is there. There is no path. But in case 2 is there, depth of the 2 is 1, because root to this node, that is depth. In case 5 is there, what is the 5? 5 root, it will consider from the root. Root is there, one link and another link. 2 is the depth of 5. Okay. So then next, height of the tree. What is height of the tree? It is the total number of nodes on the path from the root node to the deepest node in the tree. How many nodes are there? That will be considered, that is height of the node. A tree with only a root node has a height of 1. Okay. So root node height is 1. Okay. So in case, how many nodes are there? 11, 5, 2, 1. In case the depth means for 11 it is 3. But height means it is 4, because 4 nodes in the path are there. And complete binary tree. What is complete binary tree? A complete binary tree is a binary tree that satisfies two properties. First one, in a complete binary tree, every level except possibly the last is completely filled. What is completely filled means? Each node have two children. Must be they have two children. Okay. One have two children for level 0 over, level 2, two children over, level 3, 4 children. Then this is the last level. It may be less. There is no problem. But previous level must be complete. Then last. Second, all nodes appear as far left as possible. So from left side, it should be completed. Okay, right side if pending, there is no problem. So in case right side pending, left side there is no leaf node, means that is not a complete binary tree. Next one, extended binary tree. What is extended binary tree? A binary tree is said to be an extended binary tree if each node in the tree has either no child or exactly two children. Okay. Nodes having two children are called internal nodes. Nodes having no children are called external nodes. Okay. So that means in case node having two children, that means here this node have two children. So this is called like internal nodes. Okay. So nodes having no children are called the external nodes. So this node have no children. So this is external node. In this figure, internal nodes are represented using circles and external nodes are representing as squares. So these are the external nodes. To convert a binary tree into extended tree, every empty subtree is replaced by a new node. The original nodes in the tree are in the internal nodes and the new nodes added are called the external nodes. Now, representation of binary tree. How to represent binary tree in memory? Okay, in memory, how to represent it? So in memory, once we are creating the binary tree, how it will be represented? It's have two types. One is linked representation, another one is sequential representation. In linked representation, I already told it's how data and two pointer, left pointer and right pointer is there. The left pointer will pointing to the left subtree, right pointer is pointing to the right subtree. So for that we are using the structure creating two pointer with one data. This is the diagrammatic representation of linked representations. So the one is the data, it's how two child. So left side pointer is pointing to the left subtree, right side pointer is pointing to the right subtree. So the leaf nodes have no children means that is how left pointer and right pointer are null values. Here the cross symbol is mentioned for null values. There is no children. This is memory representation for the previous diagram. So in this diagram, how it is represented. So initially we have the pointer is pointing to the root node where it is stored. So the root node is 1, the root node have stored in the address of 3. But it's how left subtree and right subtree. The left node in the 5th location, right node in the 8th location. In the 5th location 2 is there and 8th location 3 is there. So left side 2, right side 3. So example we have to consider 6. Where 6 is there? 6 is in address 20. But 6 have left subtree and right subtree. Left is in the second position, that is 10, and right is 16th position, that is 11, that is stored like this. Okay, clear. Finally, where is the next free space available? That will be pointed to the next pointer. Sequential representation of binary tree. So sequential means we know that already array is used to represent the sequential representation. So here one dimensional array is used for representing sequential order. So based on this diagram, this is the first node, it's the first position. Then level 1, these are the leaf nodes, left first and then right second. Okay, so 20, 15, 35. Next level 2, 12, 17, 21, 39. 12, 17, 21, 39. Sequentially, it is arranged. Then next it will start from level 3. In level 3, first node there is no child. So 2 spaces are there. So 2 free space is there. Then 16 and 18 is there. Then there is 2 nodes are not there. So 2 free space are there. Then remaining 2 nodes are there. But it is easy to allocate, but it's how the problem for occupying more memory. So that's why we will go for linked representation. We are not using sequential representation because of it's wasting of memory. Next, binary search tree. What is binary search tree? Binary search tree, also known as ordered binary tree, is a variant of binary tree in which the nodes are arranged in an order. Which order? Normally, so left side of the root node should be less than of root node. Right side of the subtree must be greater than of root node. So it will be followed entire tree, that is binary search tree. So here 8 is there. So 8 is the root node means below 8 will be in the left subtree, above 8 in the right subtree. Same like for all the nodes. Here in case we will consider 6, 6 left side less than of 6, greater than of 7. But we will consider the 3, if entire should be the greater. Okay, entire tree should be greater of this root node. Next one, expression tree. So we can represent the expression tree using binary trees. So like we can store algebraic expression using binary trees. So first a minus b and c multiplication d, both will be added. Based on the brackets we are making the expression tree. The last tree is tournament tree. What is tournament tree? Normally we know that match, if many players are there means we will consider who is winner, who is loser. Okay, so it is a selection tree. So each external node represents a player and each internal node represents the winner of the match played between the players represented by its children nodes. These tournament trees are also called winner trees or loser trees. Winner trees because they are being used to record the winner at each level. Loser trees, it will record all loser at the each level. So example, here these 8 players are there, A, B, C, D, E, F, G, H. So the tournament will be happen to 2 persons. So from the first 2 person who is winner in the next level. So same like that it will be happen. Finally, the top winner will be in the topmost position. That is tournament. So now, the outcome of this presentation. What is the outcome of this presentation? Now you know what is tree, what are the types of tree, how we can classify the trees, you know that. So now I given the sample questions for your reference. Thank you for your spending time for watching this video.